Alright, so this is part two of the day, last Thursday, February 6th, that you may have missed due to snow. And for those of you who are watching this again, who attended lecture, I've added a couple of visuals to hopefully make it more interesting. It's hard to just talk to slides. Alright, so we ended off with a discussion of glycogen and how important glycogen is to the human body. And how athletes build glycogen if they provide their body the complex carbohydrate storage form by giving their body carbohydrate slowly. This is what a cross-section of glycogen looks like in the liver. And as you can see, there's the blue cell here at the bottom. The black dots are glucose. And so this whole mass here is glycogen, and these glucose molecules are held together as glycogen. This is another image of glycogen, and this is showing the chemical bonds between them, and the black dots represent glucose. So you can see, just like our image, we have these branch chains. This being a representation of glycogen, so branch chains of glucose. Now, moving on to our discussion of fiber. Fiber is different in that we're going to eat it. Glycogen, again, is in the human body. Starch is in our food. Cellulose is also in our food. Realize that fiber, there are many different types of fiber. They are different chemical bonds than you find in starch or glycogen, in that the human body cannot digest them. It's still glucose. It's still glucose plus glucose plus glucose. But see the tidy rows. See how glucose is lined up in tidy, tight, compact rows. So I tried to find an image that was hopefully interesting to show that, and I found this image of a fiber optic cable. And what this would be is, like, this is a strand of fiber. This individual piece is like I guess that's plastic, is like a chain of glucose plus glucose plus glucose. This is the chain of glucoses here. See how, unlike glycogen, it's not branched, it's not coiled like starch. It's a tidy, compact row of glucose. And what happens with fiber is it's a tight mesh. So this would be like a stalk of broccoli, the way a broccoli stands up tall like a tree, the thick part of like popcorn seeds. So let me show you another image I found to discuss fiber that I thought might make the discussion more interesting. This is prairie grass. And this is what cows were initially put on our planet to eat. And see how the stalks of grass are stiff. And if we as humans were to eat this grass, it would come out very much like it went in that these fibrous stalks would not be digested. A cow, when it spits up its cud, can digest this. But since humans don't have that capability, what happens as we take in fiber is that we don't digest it. These individual strands of glucose held together go into our gut. We chew up, say we chew up the pieces of fiber into smaller pieces, but it hits our stomach. The acid doesn't do much. It hits our small intestine, and our body is like, wow, I don't have the enzymes to digest this. So some types of fiber, water-soluble fibers, will sit in our gut, and bacteria will go to work on them and partially digest them. And as this bacteria goes to work on the water-soluble fibers, it produces side effects. Gas. The side effect of eating lots of fiber, legumes. Some people will get gas from cabbage and broccoli. Some people get gas from oatmeal, especially if they've not consumed a lot of fiber. Well, insoluble fiber, like the popcorn husk, is different. We can't digest these bonds, so what happens is water is pulled from your tissues into this mass of fiber, breaking up these tightly compacted strands. And so as it bulks up and moves through the intestinal tract. It moves through the gut. So what this is showing is our colon. So by the time this bulked up mass gets to the colon, it puffs out, and so it's going to provide bulk against which this colon, this lining, it's going to make it work. Because realize this is lined with muscle tissue. So it's going to exercise your gut. So the fiber is going to act like a scrub brush, and it's going to scrub out pieces and particles of leftover food as it moves through and goes on to the rectum. Well, these diverticula, which can grow into what we call colon polyps, and here shows one. See the rings of a healthier part of this digestive tract. That's leftover food there. Uh, these are those pouches that you see. Pouches. But if you don't exercise these pouches, you'll get flabby spots. And so you'll get an outpouching. This is not full of leftover food. If it becomes full of leftover food, uh, it'll fester and be infected and harden, and now you have a colon polyp. And if you have a festering, infected cell, such as, look at this mucosa. It is sensitive tissue in terms of needing to stay wet, needing to stay exercised. There's a lot of blood supply there. You have to work it out. If it's not, old food will sit in here, fester. These cells will rapidly divide and cause what? Rapidly dividing cells? Cancer. So this is why we want fiber. We want fiber to scrub out that cell surface, or this, muscular lined tube. We want it to be like the scrub brush. So, are carbs fattening? Should we eat more fiber? Well, carbs are not fattening, and we should get a diet that is containing lots of fiber and from whole foods. So let me go back, and we discussed fiber. Let me go back and show you once again, as way of review, the different types of carbohydrate so that you can begin to see that this is true. So we talked already about starch being molecules of glucose all put together. We talked about how plants, whole foods in particular, are the best ways to get those starch. And then we're going to head into, with this knowledge of starch, glycogen, and fiber, we're going to head into talking about how it's broken down. That's enzymatic digestion. We're going to see that the mouth begins the process of starch digestion. There are actually enzymes in your saliva, salivary amylase, that start starch digestion. Not much happens in the esophagus, but by the time it gets to the front lines of nutrition, the small intestine, it's going to break down into glucose. The enzymes amylase breaks down starch, maltase breaks down glucose, so that eventually glucose is absorbed. And again, here's glycogen, and it's so important because in exercising muscle, it provides immediately available energy, glucose. Interesting about glycogen, you can't eat it. You cannot eat glycogen. Immediately upon slaughter, the animal breaks down its own glycogen. So it's stored in the muscle, about a pound of it. Athletes can have 3 to 4 pounds of it. And with each pound of glycogen goes 3 to 4 pounds of water. So highly branched. Here are the different types of fiber. This is what I was trying to get to. Soluble and insoluble. As I mentioned with the picture of the gut and the picture of the fiber optic cable, some of those tightly compacted strands of glucose are not digested at all. That's the insoluble fiber. That is the cellulose hemicellulose. This is cardboard. Okay, this is when you buy that cardboard cereal, bran flakes, fiber flakes. Why eat it if it doesn't taste good? Rather, get your fiber from whole foods that taste good. I mean, if you like bran flakes, eat them. But you don't have to get these insoluble fibers in ways that are not palatable. So it looks like strands of tightly compacted glucose all hooked together. It provides bulk against the colon. It acts like a scrub brush and cleans it out. It makes you full and prevents constipation. Water-soluble fibers are very different. Gums, celluloses, pectin, guar gum. These gums, locust bean gum, uh, bacteria do go to work on them a little bit, beginning to break them down, and they give you side effects. What's interesting about these water-soluble fibers, like beans, oatmeal, if you eat them more frequently, the bacteria that break them down stay in your gut. They stay behind. So if you eat beans a couple days a week, those bacteria will stay behind, and the next time you eat beans, you won't get the side effects. Here's a benefit of those water-soluble fibers, the kinds bacteria go to work on. They slow down the precursor. They slow down the absorption, the precursor of cholesterol. They're called bile salts. They slow down the absorption of glucose, postprandial glucose elevation. So postprandial means after you eat. So we're going to reduce postprandial glucose absorption. They're going to make you feel full. And again, get them not individualized in Metamucil or whatever those fiber benefits supplements, but get them from whole foods so that you get both soluble and insoluble. And we talked about juice. Look at how wonderful fibers are in whole grain. People joke about my beans, one of my favorite foods, but look at the benefit here. Look at all of the soluble and insoluble fibers. Soluble in the light line, insoluble in the dark line. Whole fiber, cleaning out the gut, the water soluble and the soluble, insoluble. So beans are a great source. One easy way to get more fiber in your diet is to switch from instant oatmeal to old-fashioned oatmeal. You get both types of fiber. Do we get enough fiber in our diets? No. Most students, when they do their diet analysis projects, the project I used to have where they wrote down everything they ate for 3 days, they found they ate about half the amount of fiber they were supposed to. So here's the bottom line recommendation about carbohydrates. For every 14 or for every 1,000 calories you consume, you should get 14 grams of fiber. And roughly half of your calories should be from carbohydrates. Remember, those percentages are what we call the AMDR. So I hope this discussion of starch versus glycogen versus fiber was helpful. I would know some benefits of fiber and certainly the difference between the water-soluble and the insoluble fiber. So I'll see you on Tuesday.